All right, before we start isosceles and isosceles and equilateral triangles, we're going to need this later in the lesson and probably for the rest of the week. Use congruent triangles to prove corresponding parts of congruent triangles are congruent. CPCTC. Anybody want to guess what that stands for? Corresponding parts of congruent triangles are congruent. CPCTC stands for corresponding parts of congruent triangles are congruent. So here's an example of CPCTC. Are these two triangles congruent? Yeah? How do you know? SSS, because we're going to use the reflexive property to show that those two sides are the same. And all three sides would be congruent. Okay, so complete the statement. Angle A is congruent to angle C, but they aren't marked congruent. So we have to say why they are congruent. CPCTC. So again, that means if we know the triangles are congruent, that means all of their corresponding parts are also congruent. So I can go mark them if I want. If I know the triangles are congruent, then all the corresponding parts are also congruent. CPCTC. All right. Using the base angles theorem, we've got a triangle that's isosceles where we have two sides. Actually, this says at least two congruent sides. So that means three congruent sides could be isosceles. But we call that something else. Three congruent sides? Equilateral, yeah. Okay. When we have an isosceles triangle, there's some vocab that has to do with certain parts of it. The vertex angle is the angle that is formed by the two congruent sides. The vertex angle is, you see how the two congruent sides make that vertex angle. The base angles are the angles, how does it say it over here? The two angles adjacent to the base are called the base angles. So the base is across from the vertex angle. And then the two angles that are touching the base are called the base angles. Base angles theorem says if we know we have two congruent sides, that means that their angles that are opposite those congruent sides are also congruent. Base angles theorem. So if we have an isosceles triangle which has two congruent sides, we also have two congruent angles. The converse of the base angles theorem says if I see some triangle laying around that has two congruent angles, guess what that means? It has two congruent sides as well, the ones that are opposite it. So it's just opposite of what I just said here. If we see the two congruent angles, then we have two congruent sides. If we have two congruent sides, then we have two congruent angles. What kind of triangles are these? They're isosceles. Example 2. I think this is example 1. It's example 1. I don't know why it says 2. My bad. Oh well. Example 1. Using the base angles theorem. In triangle, oh, I know why. I just forgot to, never mind. Not important to you guys. In triangle DEF, DE is congruent to FD. We have to name two congruent angles. Angle something is congruent to angle something else. What do you guys think? Aaron? FNE, right. So then what's angle D called? The vertex angle. Oop, I wasn't writing that on the screen, I see. Angle D is the vertex angle. We're already on the back. proving the base angles theorem. So we are given that side AB is congruent to side AC. So I'm going to go over here and mark that they're congruent. We are given that AD is the angle bisector of BAC. So I'm going to go ahead and put down that AB is congruent to AC, and AD is the angle bisector of angle BAC. Given. We are trying to prove that angle B and angle C are congruent. All I know right now is that AB is congruent to AC, so that's a side. I know the angle bisector of AD is the angle bisector of BAC, but that doesn't over here say that anything's congruent. If I know that AD is the angle bisector of BAC, what is that telling me? John? It has to be 90 degrees? Is that what you said? Does that look like it's 90? Oh, but I don't know anything about where it's hitting down here. I just know that it bisects angle BAC. So angle BAC is what's being divided in half. Lynn, what are you thinking?
Both sides are equal. So
Both sides are equal?
Well, when it splits down the middle of the triangle, they're two equal parts. Yeah.
Have we proved that in here? What?
The angle bisector.
So angle bisector has nothing to do with a triangle. Angle bisector bisects an angle. I'm actually looking up the definition right now for angle bisector so we could actually look and see what it says. Angle bisector, a ray that divides an angle into two angles that are congruent. So if I know that AD is the angle bisector of BAC, that's telling me two angles. That's what it's telling me. What angles are congruent? BAD. I'm going to mark it so you can see it. BAD, and what did you say? CAD. So angle BAD congruent to angle CAD. That is by the definition of the angle bisector. You saw me look it up in the glossary. Okay, in order for me to prove that these two angles are congruent without using the base angles theorem, because that's what we're proving right now, in order to prove that these angles are congruent, I'm going to have to show that the triangles are congruent, and then I'll know those angles are congruent. Is there a way for me to prove the triangles are congruent right now? I have side and I have angle. Where's the third S coming from? So I have to list that over here. So what am I going to say? AD is congruent to AD. So for this one, the triangle, if I do like BAD and CAD, like AD is the same direction for both of those. Sometimes it's the other way. And that would be what property? Reflexive. Good. So do I have triangles congruent? I have to list that. So I'm going to say triangle, but we say BAD congruent to triangle CAD by what? What's the reason? What's the reason? I'll give you a hint. You just took a quiz on these reasons. Well, maybe that's not a good hint for some of you. Huh? SAS, right. Side, angle, side. I even wrote it over here. Side, angle, side. So I know the triangles are congruent. What does it mean if the triangles are congruent? All the corresponding angles are congruent. All the corresponding sides are congruent. All the corresponding parts are congruent. So can I now say angle B is congruent to angle C? Why? CP, CT, C. Corresponding parts, congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. Okay? Copy and complete. I already copied it for you. If segment HG is congruent to segment HK, if HG is congruent to segment HK, angle what is congruent to angle what? I can say angle G congruent to what? I can't say angle K because there's like 3 of them there at angle K. So how do we say this angle K? David, how do I say this angle K? How do I say this angle? Like 3 letters. Give me 3 letters.
Oh, like
GKH. Sounds good. That's why I gave you a really weird look like. All right, if KHJ right here is congruent to KJH, then what is congruent to what? Ryan? HK, segment HK, what? Well, HK and KH are the same. I want you to give me a different one because I gave you 2 base angles. So by base angles theorem, actually the converse of the base angles theorem, which is on the front page, if you don't know what I'm talking about. If you, as in anybody sitting out here, don't know what I'm talking about by me saying the converse of the base angles theorem, he says HK is congruent to what, Ryan? Did you say KJ?
Yeah.
Okay. If I say HK, if I start on that base angle and I go to the vertex, then I'm going to do the same order over here. I'm going to go base angle to the vertex and I'm going to say JK instead of H. Wait, J instead of KJ. JK. Right? Okay, last part. The corollary to the base angles theorem. This says if a triangle is equilateral, then it is equiangular. This is a corollary to the base angles theorem because this is an isosceles triangle. See? It's got at least two sides that are congruent. So the isosceles triangle also has two base angles that are congruent. But since it is more than isosceles, because it is equiangular, I can actually turn the triangle and make different angles, the base angles, and therefore those angles have to be congruent. Or I could turn it a different way, and these angles are going to be congruent. So that's where we have the corollary to the base angles theorem. If it is equilateral, it is also equiangular. The corollary to the converse of the base angles theorem, that's a lot of words. If the triangle is equiangular, then it is also equilateral. So if I know all three angles are congruent, then I know all three sides are congruent. So here's a triangle. It's lightly copied. It's marked that all three sides are congruent. We have to find the measurements of angle P, angle Q, and angle R. And I'm not given any angle measurements here. All I know is that all the sides are congruent. Is there something else that I know because all the sides are congruent? Okay, here are a few things. Avni, go ahead and say what you said. All the angles add up to be 180, right? If I took angle P plus angle Q plus angle R, they would equal 180 degrees. What also do I know? Whose they are all the same? Who's they? All of the angles are congruent because if it is equilateral, then it's also equiangular. So these are all going to be the same amount. So if we take that 180, we divide it by 3, we'll get 60 degrees for all three of those. That is never not 60 degrees. Every single equiangular triangle has measurements of 60 degrees. And then the last one, using isosceles and equilateral triangles, find the values of x and y in the diagram. So here's x plus 1, and this has 2 arcs marked. There's 2 arcs marked here. This one has all 3 arcs marked the same. There's a 4, and there's a y. What's y equal? 4. Why? All the angles are congruent, therefore all the sides are going to be equal, making this side 4. So what's x? What's x? I thought I heard a 5 in there. Okay. The assignment is on big ideas. We will be doing a come prepared. If you have questions about the quiz,